Hello guys, I am Dr. Radheshyam Dharnia and today we will discuss about some examples of moment of inertia and their solutions. So first example is three particles each of mass m kilogram are kept at the vertices of an equilateral triangle as shown in this diagram. Find the moment of inertia of the system about an axis passing through its center of mass and perpendicular to the plane of triangle. So we have to find moment of inertia of this system about an axis which is passing through its center of mass and perpendicular to the plane of this triangle. So first we have to find, as we know, the center of mass is at point O because of symmetry, and by the symmetry OA, OB and OC distances are equal. So let's assume an right angle triangle OBD. So this angle theta is 30 degree. Why this angle is 30 degree? Because this is equilateral triangle. So angle ABC is equal to 60 degree. So this theta is half of 60 degree because this line intersect at the midpoint of AC. So this divide these both angle in equal parts. So this angle is also 30 and this angle is also 30 degree. So OB is equal to OA is equal to OC is equal to BD upon cos theta. So theta is equal to 30 degree. So BD is equal to, as we know, this whole length BC is 1 meter. So BD is 1 by 2 meter. So BD is equal to 1 by 2 meter. And we know cos 30 is equal to root 3 by 2. So the length OB is equal to 1 by root 3. So now we know that I is equal to mr square. So these are three particles, so we calculate individual moment of inertia due to individual particle. So first we calculate of particle A. So particle A, then it is OA distance far from center of mass. So MA OA square. Particles MB is OB distance far. So MB OB square and MC OC square. So we know MA is equal to capital M and OA is equal to 1 by root 3 whole square plus MB is equal to M and OB is equal to 1 by root 3 whole square plus MC is equal to M and OC is equal to 1 by root 3 square. So this 1 by 3 plus 1 by 3 plus 1 by 3 becomes 1. So the answer is m kilogram into meter square. Next example number 2. Three particles of masses 1 gram, 2 gram and 3 gram are kept at point 1 centimeter 0. कोऑर्डिनेट्स दे रखे हैं इन तीनों मासेस के. फर्स्ट के कोऑर्डिनेट है 1 सेंटीमीटर 0, सेकंड के है 0,5 एंड थर्ड के है 4,3 in centimeter. Find moment of inertia of all three particles in gram into centimeter square about first x axis, second y axis and third z axis. So first we saw that where these particles are kept. So this is x-axis, this is x-axis, this is y-axis. Coordinate of 1 gram is equal to 1 centimeter comma 0. So 1 centimeter on x-axis and on y-axis it is coordinate are 0. So particle first is here and particle second is at 0 comma 5 centimeters. So on x-axis it is 0 and on y-axis it is at 5 centimeter. So second particle is here and third particle are present at 4 centimeter comma 3. So 4 centimeter on x-axis and 3 centimeter on 4 centimeter on x-axis and 3 centimeter on y-axis. So here is third particle. So now we calculate moment of inertia about x-axis. So Ix is equal to m1 r1 square plus m2 r2 square plus m3 r3 square. Here r is perpendicular distance of the particle from respective axis. So r1 is equal to m1 is equal to 1 gram. What is r1? r1 is perpendicular distance of particle from the axis. About which axis? Moment of inertia is asked. So r1 is present on x-axis and moment of inertia also asked about x-axis. So r1 is equal to 0 plus m2 is 2 gram and r2 is perpendicular distance from x-axis. So this is perpendicular distance, this is 5. So 5 square plus m3 is equal to 3 and r3 is equal to perpendicular distance from x-axis, so that is 3. So this is 2 into 25 means 50 plus 9 into 3 27. 50 plus 27, so it is 77 gram into centimeter square. Now we calculate about y-axis. So Iy is equal to m1. m1 is 1 and the perpendicular distance, this is y-axis, so this is perpendicular distance, this is 1 square plus m2 is 2 and r2, the perpendicular distance is 0 because particle number 2 is on y-axis. So this is 0 plus 3 into the perpendicular distance is this and this is 4. So 4 square. So this becomes 1, this becomes 0 and this becomes 16 into 3 48. So whole is 49 gram into centimeter square Iy. And now we see Iz. So Iz is this axis passing through this and perpendicular to this plane xy. So the distance of particle 1 gram becomes this 1 centimeter. Okay, and particle second, so this is perpendicular distance 5 centimeter plus Now, what is the perpendicular distance of this axis from particle number 3? So this becomes perpendicular distance. Okay. So this becomes R3 is equal to 3 square plus 4 square whole root. So this becomes 5. So 3 into 5 square. So this is 1. This is 25 into 250, and this is 25 into 3, 75 to 75 plus 50 plus 1. So it becomes 126. And the third example is the moment of inertia of a uniform semicircular wire of mass capital M and radius r about a line perpendicular to the plane of the wire through the center. So this is a semicircular wire, this is the center point O, and we have to find moment of inertia of this semicircular wire about this point and perpendicular to the plane of this wire. So as we know, in ring we know that about this axis which is perpendicular to the plane of ring, the moment of inertia is mr square. So here mass also m, radius also r, and distribution is like ring. So I becomes mr square. And the example 4 is find the radius of gyration of a rod of mass m and length 2l about an axis passing through one of its end and perpendicular to it, perpendicular of its length. So this is rod and mass of rod is m and length is 2l. So we have to find radiation of gyration of this case. So first we find moment of inertia of this system about this axis. So this is I is equal to 1 by 3 ml square. I is equal to 1 by 3 ml square. Here L is equal to 2L. So I is equal to 1 by 3 m into 2L square. So it becomes 4 by 3 ml square. So this 4 by 3 ml square is equivalent to m k square. So from here m is cancelled out by this m, and k is equal to under root 4 by 3 L. So it becomes 2 by root 3 L. Now next question.